Hello, I'm Neil, and in this video we're going to talk about the system development lifecycle, and let's get into it. The system development lifecycle has four main phases: inception, discovery and running, maintenance, and decommissioning. Each one of these is important but have wildly different lengths, so let's go into each one in a little bit more detail. This video, and indeed this whole playlist, is based on my book, which is available on Amazon now. The first stage of the software development lifecycle is inception. This talks about several people, the players, the what, the why, the how, and of course the how much. The first focus is what. What problem are we trying to solve with this new software? It's important to have a clear idea of what the problem is so that you can come up with a solid solution. However, we don't need to come up with a complete solution on day one. That's what iterative development's all about. The second question is who? Who are we going to work with? Who's the software developed for? Who's going to get the most value out of using it? Once we've identified the who, we can get more detailed on the what. Working closely with a group of our target audience for this product enables us to really hone in on what they want, what they need, and what they're most likely to buy. Armed with that information, the team, or just you, can start to put together an MVP, a minimum viable product. This is the smallest possible amount of coding you can do to provide what looks like the end product to the customer. Examples of that might be just a static website, where the customer clicks through certain pages, but there's no actual interactivity between the pages. That might be added later. The development is most expensive at this time. To get a working prototype might take a few $1,000s or pounds. With this early prototype, you can test the idea with your audience, who we identified in the who, against the what. What is the problem they're trying to solve? And does the software we delivered in the MVP actually solve that problem? And because it has some cost to it, we of course need funding. Initially from your pocket, manager's pocket, the sponsor's pocket. At some point during the MVP, maybe even the customer's pocket. The funding needs to extend much further than just the development of the MVP. It also needs to extend into the development of the product. In order to get a product we can charge for, depends on what the solution is. As I mentioned earlier, you might be able to get the customers to pay for some element of the product straight away. As this is all about DevOps, let's talk about environments. One of the DevOps principles is automation. Having the environments look the same enables us to automate into new environments and deploy across those environments without any nasty surprises. First environment we need is the developer environment. This is usually a local environment, perhaps running Docker. This makes deployment easier, and it's small enough at this stage to run on the developer's laptop with all the tests and modules and stuff necessary. Once we want somebody else to see it, share it with our customers for instance, we will need infrastructure. That infrastructure might necessarily be created by you. There's services like Heroku or AWS Serverless that can provide enough framework for you to install your software without having to worry about much hardware or infrastructure. If you want to deal with the servers as well, then the minimum is a server and probably a load balancer. Although the load balancer can be delayed until we need two servers. A server on its own is pretty useless. We need networks in order to connect it to the internet. If you're launching it in a cloud provider, this is already given for you, free of charge in a way, along with security. Inbound IP addresses and those attached to the instance, in AWS's case, can be secured with security groups, so that only the ports that you know about are open, like the web interface, HTTPS. The other services that may be running on that box, like Mongo if you need a database, or SSHD if you want to copy stuff into it using Ansible, they can be hidden away and only accessible from specific IP addresses or networks. A more elaborate solution would be to have a VPN into a private network, but again, not needed at the startup stage. Once you've got your service up and running, it needs to be discoverable. And for that we use DNS and service discovery. Depending on how you're hosting it, depends on the service discovery, but either way, If a customer at home needs to be able to see it on their laptop, they need to connect to the internet, get to a DNS server, and that will give them the information their laptop needs to connect to your server. Additional bits to make the deployments easier: secrets. This is where you've got specific secret information that's in your application. It might be an API for an external service, or it's SSL certificate so it can talk over HTTPS internally. You don't want those packaged in the actual application, but you want those deployed along with it at deploy time, so we can manage secrets within the environment. AWS provides a secret manager. There are other solutions, like HashiCorp Vault. When building and deploying the software, it's handy to have access to caches, both artifact caches and source caches. And initially, of course, you can store these things on your laptop, but if you're starting to grow into a team, you might want to share resources for these. Download all the dependencies for your app at build time, and then when you compile it into something that's deployable, store that in some sort of zip file on a safe storage. It could be an S3 bucket, or could be something more advanced like Artifactory from JFrog. If we're dealing with EC2 images or Docker images, then something needs to build those as well. This is a good interim step to have all those dependencies on, so we don't have to ship them with the deployment. If we're building a Python app, we can make sure that Python is already available on the server. That way we don't have to install it as part of the deployment. And once we've got something deployed, we want to be able to monitor it for performance, make sure it's not going too slow or crashing out, and the logs, so that when it does crash out, we can at least get the log messages to understand why and fix the bug. So we've got our MVP deployed, and customers can get to it. Hopefully they like what they see. We need to get feedback from them, so that if they don't like what they see, understand what we need to change. Maybe the MVP has the bare minimum features, which is correct, and then we want to add new features based on the feedback from our customers. We can do this through customer research, and then develop those features, and of course fix the bugs we find. Another core principle as DevOps is fast feedback, whether that be from the application and the systems that are running the application, or from the customers using it. The faster we get the feedback, the faster we can make things better. Continuous improvement. Just maybe after enough cycles of feedback and features and bug fixing, we'll get to production. Maybe you already did a production deployment. Someone always has a testing deployment, and in some teams it's called production. Once the application is deployed to production, we want to make sure we've got a solid pipeline of building, testing, and deploying so that we can get everything out as quickly as possible to our customers. It doesn't offer any value to anybody until it's deployed to production. Using iterative development, we want fast and frequent deployments, either for features and bug fixes or for security patches. If your application has dependencies, you might find that at least one of those gets changed every day. And for the smooth running of the platform, and for situation awareness, we want monitoring and performance. We want to see that everything's working fine. More customers means more servers, or more capacity. The final stage of the software delivery lifecycle is decommissioning. Some services get this far. Some, for strange reasons, unknown to me, don't get this far. It should be inevitable that anything that gets created gets decommissioned. It's superseded by something. On the other hand, it might just turn into legacy, which means there's enough interest to be running, but not really a lot of interest. If it's not legacy and it truly is time to see it go, then decommissioning the system is all we have left. We want to do this because it saves costs. We don't want to pay for something that's not being used. We've used some of the other DevOps principles, like automation, testing, creating, and destroying. The destroying bit should be easy. Click a button, and it's all gone. For development environments, this should be a weekly occurrence at a bare minimum. You don't want to pay for the servers over the weekends if nobody's using them in your development environments. Only production needs to be active for customers to use it. Next time, I'll be talking about building servers. How to do it, what bits you need, and how easy it can be. After all, at the Werner Vogels, he said, servers are a software component. You can switch it on and off. So let's make it that easy. See you next time.